Okay, you're going to start today with a warm-up live quizzes, and let's just make sure we know what we're doing with the vocabulary. So for this one, I don't like the way it's worded, but make sure you understand it can be either an enlargement or a reduction, and we're dealing with what? A dilation, okay? I realized on the benchmark this morning that a lot of the benchmark talks about understanding dilations. So make sure you understand these. These questions aren't that difficult, okay? If we kept going through this one's actually super important too that we know. The figure after a transformation, after, is called the image. The one that's before is the pre-image, okay? So the one after is the image. All right? Does a dilation always produce a congruent figure? What does congruent mean? Congruent means the same, the exact same, okay? It does not. A dilation does not. A dilation never produces a congruent figure. Are they the same size? They're not the same size. They're the same shape, but not the same size, okay? Dilations changes the size. So make sure you know that. All right, so here's the kind of question. Dilation always produces a similar figure. Similar figures have the same. So similar figure is super important too, that you know that. That's like little brother, big brother, okay? When you have family that you look similar, you're not the same size, but you may look the same, which we're going to call shape, all right? So they have the same shape, but not the same, but different sizes, all right? All right, look at the image. Did it actually reduce or enlarge? And make sure when you look at images that you start with the ones that don't have the prime signs. These have little apostrophes that are prime. That's the image. This is the pre-image. So this is the first one. This is the second one. It's pretty obvious to see that it's getting smaller. So when it's getting smaller, it's a reduction, okay? Reduce. All right. As I keep going through, you can get through this pretty easily. Let's see. For this one, we didn't really talk about it, and maybe we have, but we're comparing sides. So if you compare this side to this side, it was multiplying by 4. So you're multiplying by 4. 6 times 4 is 24. So what would you have to multiply 9 by to get to x? It would be 9 times 4, which is 36. All right. As we keep going, scale factors, you're going to cut this in half. Cut that in half. Whenever you multiply by a half, you're cutting it in half. This one you're going to multiply by 2. So multiply this coordinate by 2. All right. This one, remember translations. It's going 3 units to the left and 5 units down. 3 units left, 5 units down. Remember that one, okay? And I'm going to get into, okay, reflections. We talked about this last week. If it's an x-axis reflection, the x stays the same and the y changes. The x stays the same, so 9 stays the same, but the 2 changes to a positive 2. That's on an x-axis reflection, all right? On a y-axis reflection, the y stays the same and the x changes. The y stays the same and the x changes, okay? Make sure you get those straight. All right, as you keep going through this, there is a little bit of exponents in here, which is great. Remember what to do with your rules on exponents. You're adding these. Don't forget there's a 1 there. So when you're looking at this one, x2, 3, that's 5. 4, 5 plus 4 is 9, but there's an invisible 1 here. So it's actually 10 is your answer here. And this one, you think you should multiply? No, it's not that rule. This is still going to be adding the exponents. So 16, okay? This is still adding the exponents. Now, if it looked more like this, if it was like x2 with a parenthesis and then like 5, but it didn't look like that. It had it a little different than that, okay? And I think I want to go down here just to show you a couple dilations. If we're going to do this point B by a scale factor of 3, it's at 0, 4. 0, 4. So if you're multiplying by 3, you would multiply 3 times 0, which would be 0, and then 4 times 3, which would be 12. Okay? All right, guys, do the best you can on this. This is a good review for what you have. You guys know the rules. Dilation, when it's a scale factor greater than 1, the dilation's an enlargement. Okay, that's true. All right, now, after this, all right, now we're going to get into review. So with the Desmos, this is going to be super easy. You can get through this no problem. There is quite a few slides, but towards the end it gets kind of crazy with the rotations, which is brand new to you. So I want to make sure you take that serious. All right, so go for this one. 5 units right, and 1 unit up. No problems at all. Miss Alonzo, feel free to push pause because I'm going to go through quickly through this to get through the video because you guys already know how to do this. We're going to move on. So, all right. So your image should be up here somewhere. You can go ahead and Miss Alonzo and also share other kids' screens if you'd like to see how they did. Kids love that. So share their work. Feel free. All right. We're going to go to the next slide. Reflect over the x-axis. All right. Go ahead and push pause. This should look here, right? T prime. Is it B? Hold on. That's wrong. So when you're doing this one, actually, no, that's right. We're 3 units away. 3 units away. 3 units away. That's B prime. And then G prime is going to be right above this. Okay? And what did I do wrong in this whole problem? I did it over the y-axis, didn't I? So that's wrong. That's over the y-axis. I should have done it up here over the x-axis. My bad. It's okay. Make sure you label this properly. Hopefully we see some good answers. Miss Alonzo, feel free to share anybody's answers that are great, solid. Use the typing thing too. If you want to type out like G prime, you can do it that way too and get fancy. All right. And that's not where that was supposed to be. That was a different spot. All right. Over the y-axis, go for it. Push pause. All right. Now translate with the rule +4 +2. Make sure you remember your rules. +4 means we're going to go to the right. +2 means it's going to go up. So it should be up here somewhere. Hopefully we get a good example shown to the class. All right, describe in words what happened here. This is interesting. I like this one. Make sure you talk about what happened in words here. So you're going to start here, though. You always have to start with the A that doesn't have the prime sign. And what happened? And if you want to actually go, just go right 1, down 3. But if you also wanted to do x plus 1, y minus 3, that's also a great way to describe it. All right, this one's great. Okay, this one's awesome. I love this one because it's going to be similar to what you're going to see in the benchmark. First, reflect it over the y-axis. So give me that triangle first. And how about you choose that, do that one in red. Give me that triangle in red, and then give me the second one in blue. And I'll show you an example of this. The next one you're going to do all on your own, but you guys can actually, you do this on your own right now, and you'll see my example in a second. So if I'm going to go y here, y is going to be here. All right, if I'm going to go m here, m is going to be here. If I'm going to go G here, the new G is going to be here. And that's over the y-axis. I'm going to use my straight line tool. And there we go. Now I said in blue, give me the translate up 4 units. So this one's going to go up 1, 2, 3, 4. And when you do that, label it y prime, double prime, 2 primes. That's the second transformation that's happened, the second one. Super simple. 1, 2, 3, 4. That's actually going to be right where that other one was. That's m prime. And then G is going to go 1, 2, 3, 4. And that's where G double prime is going to be. Okay? And there's my new one. That would be perfect. You can do this. This is not too difficult. You're just putting 2 on one graph. You guys, I have high expectations for you. This is not too tough. All right, try this one, the same idea. It may end up over here, and then you're going to go to the right, and the second one should end up over here. Push pause, Miss Alonzo, help them out. That'd be great. All right, translating left 1, and then up 2. Left 1, up 2. You got this. All right, this one's great. Can you give me the original images? The original images here, or original coordinates. So make sure you do that properly. Put all the coordinates here, the original ones, and then you're going to cut it in half. So cut those points in half. You want to take your calculator out, you can. You're going to multiply it by 1/2. That's all you need to do for this one, and then give me the new image. It should get smaller, should be in there somewhere. Okay? All right, and try to describe to me what happened from blue to green. Look at the coordinates. This is a super important problem because you're going to need to do this, okay, on the benchmark. If I look at the coordinates here, the blue is going to be, this coordinate's 1, 1, that coordinate, and you have to compare the same coordinate that's on the other triangle to make sure you see what's happening, and that's 2, 2 for this one, over 2, up 2. So you can tell that 1, 1 got multiplied by 2. So you can tell a scale factor of 2. All right? Super simple. Now this is the rotation. Oh, almost to the rotation part. This one I put up there because you're going to see this again too. What is the algebraic representation for reflecting a figure over the x-axis? We covered this in the starting quizzes. So X-axis means the X stays the same, but the Y changes. X-axis reflection means the X stays the same, but the Y changes. Which one is that? Boom. Okay, make sure you put that in your brain. You're going to need that later. All right, this one's fun. So we're going to do this one together. If I go ahead and draw a triangle in somewhere in the space provided, I want you to draw it in this first quadrant just for fun. Okay? Actually, it doesn't matter where you draw it, but let's just take a look at what happens. If I hit it, boom. All right? If I want to reset it, what do you notice that happened? And let's talk about yesterday's lesson. And if you notice what's happening, when it just did one quadrant over, if it only went one quadrant over, that's a 90 degrees 90-degree rotation. But hold on, which way did it go? Did it go to the left or did it go to the right? And it went to the left, so we're going to go counterclockwise. Counterclockwise, okay? So make sure you see that. The next couple slides, Miss Alonso, have some fun with them. If you need some help on figuring out what's going on, let's just see this one. All right, you can express that one. All right, I'm going to go to the next one. Make sure you see what's happening. I'm running out of time. That's why I'm going to go through this pretty quick. All right, what happened here? Be even more specific with your answers. And you notice it's still going counterclockwise. After you're done, I have an exit ticket for you. I want you to use your patty paper on it and do the best you can. All right, you guys, good luck.